So in the last class we have seen the how to solve problems based on the cables, right. So cable is such a structure that it is subjected to maximum tension, right. So in the last class we have seen something like this, that if suppose this is a cable and the cable is between the two support A and B, right. Let us name it as A and B, and suppose 50 kilonewton, 60 kilonewton and 80 kilonewton loads are acting on the cable. So in the last problem we have seen how to find out the various parameters so that the cable is stable and safe, right. So what are the parameters we have found out? First we have found out the most important parameter, that is the tension in the cable segment, that is tension in this segment. Let us name it as T1, tension in this segment name it as T2, tension in this segment name it as T3, and tension in the last segment, that is T4. So the cable, the most important parameter is to find out the tension in each and every segment of the cable. Then we have found out what are the support reaction, that is the vertical reaction and the horizontal reaction at A, VA and HA. Similarly we have found out VB and HB. So up till now we know how to find out the tension, the support reaction. Then the last parameter is, suppose this is the central line which is joining the two support, then also we have to find out one parameter, that is the distance of the loading point, that is how much the cable has sagged due to the application of the given load. So this is known as the sag of the cable. So see in this figure there are three sag, that is which is represented by delta 1, this is delta 2, and due to the third load this is equal to delta 3. Up till this we have seen how to find out the various parameter. So in today's class we will solve a very simple problem regarding what is the tension in the cable, and this problem is very simple. So let us see the problem. Suppose it is given that between the two support, this is the cable between the two support. Let us suppose that the length between the support is 150 meter. Length between the support is 150 meter, and the maximum depth of the cable, that is from the center line of the support to the maximum depth of the cable, it is equal to 10 meter. And this cable is subjected to a UDL loading, that is distributed load. Suppose the load is like this, the loading intensity is 10 kilonewton per meter. So 10 kilonewton per meter load is acting over a span of 150 meter. The central depth of the cable is 10 meter. We have to find out the maximum tension in the cable, right. So if these are the two support, that is A and B, let us name the two components, that is VA and HA. Similarly VB and HB. So see, this is a symmetrical structure, that is the meaning of symmetrical structure means if you divide the structure into half, both the half are the look alikes with loading respect, right. Okay. So let us solve for the maximum tension, right. So the first point, let us take moment about A equal to 0. So moment about this point we are taking as 0, right. So the VB, see HB and HA will not come into action because HA and HB and HA is passing through the line of action of the point A. So the coming into action, the force which will come into action is VB, right. So we know that moment equal to force multiplied by the perpendicular distance, right? So the perpendicular distance, that is, if this is the VB, the perpendicular distance is 150 meter. So VB into 150. See, VB is acting like this, so it is anti-clockwise, so the moment will be negative. Now let us consider the moment of this UDL loading at point A. UDL will act like this, so it is clockwise, right? So we know that clockwise moment are positive, so it is plus. Intensity of loading is 10, right? So 10 into the span between the support is 150. We know that UDL act through the middle of the span, right? So the middle of the span is 150 by 2, that is 75. So VB will come 10 into 150 into 75 divided by 150. So you will get the value of VB, and as per the symmetry of the structure, VB will be equal to VA and HA will be equal to HB, right? So VB you are getting as 750 kilo Newton. Now let us see, to find out the maximum tension we have to find out both the components, that is vertical and horizontal. Okay, so let us find out the horizontal component, that is HA and HB. We know that horizontal component is given by WL square by 8H, right? So it is equal to, W is the loading, that is 10, L square means the span, that is 150 square, divided by 8 into H, 8, central dip, how much? 10 meter. You will get the value of H, and we know as per the symmetry HA will be equal to HB. Now the last point, that is the main part of the problem, to find out the tension in the cable segment. Tension, we know tension is given by root of H square plus V square, square root. You will get the required tension. So that completes our simple problem to find out the maximum tension in the cable segment. Next class we will solve one more important problem on cable, and then we will move on to the more advanced topic on structural analysis. Thank you.